In this video, we're going to take a look at prime factorization of a number. There's two ways that we can do this. One is using a method involving a tree, and the other is using repeat division. Let's take a look at the tree method first. So let's look at the factors of 250 using the tree model. Looking at 250, there's a lot of different ways that I could divide this. I could divide by 2, I could divide by 5. I'm going to divide by 10 because there's a 0 at the end of this number, and that lets me know that 10 must be one of the factors of this number. So I'm going to divide this by 10, and I know just mentally that that's going to equal 25 multiplied by 10. Those numbers would give me 250. Now looking at 25 and 10, I know that neither one of those are prime numbers. They're both composite numbers because I can divide them further. I can divide 10 by 5 or 2, and I can divide by 25 by 5 as well. So I'm going to do that. I'm going to divide 25 and say that 25 is the same as 5 multiplied by 5, and that 10 is the same as 2 multiplied by 5. Now looking at these numbers, I cannot break 5 down any further. 5 is a prime number. And I can't break 2 down any further. 2 is a prime number. Meaning, of course, that they only multiply by themselves in 1. Right? I can only get 2, I can only divide 2 by itself and by 1. So that means that it's a prime number. So how am I going to write my final sort of answer? It's going to look like this. 250 equals 2 multiplied by 5 times 5 times 5. Notice that I took the 2 and placed it at the beginning, then the 5s. That's just me placing the numbers from least to greatest to keep them in a little bit better visual order. And the reason for that is because my answer is not quite finished yet. What I'd actually like to see is 250 equals 2 multiplied by 5 cubed, or 5 to the power of 3. The reason that power of 3 there is because I have 5 times 5 multiplied 3 times by itself. So that's 5 times 5 times 5. That's 5 to the power of 3. That's the more mathematically correct way to write that. Now to use the repeat division method, I'm going to choose a slightly more complex number so we can see how this can be helpful to us. I'm going to choose this big number, 3,675. Looking at this number, I need to sort of start at the bottom and work my way up. It's kind of the reverse of how we're used to doing our math. So it means I got to leave a lot of space when I'm actually doing my question because I'm never really sure how far I'm going to have to go. So let's take a look. 3,675. So I need to find a way to divide this number. The easiest thing for me to consider is that there's a 5 at the end of this number. That means that this number is divisible by 5. So I know that's going to be the case. I don't have this off by heart, so I'm going to use a calculator. And when I divide, I realize that 3,675 divided by 5 is 735. Now, would you look at that? Same thing, this number is also going to be divisible by 5. So, once again, I'm going to divide this number by 5. I know that again because it's got a 5 at the end, 5 in the ones column. That means I can divide that number by 5. And my answer for this one is going to be 147. Now, to be honest with you here, without really checking for a second, I really thought that I was at the end of this equation. I really thought that 147 was a prime number. It just doesn't look like any number I really have memorized that I recognize. But I have to check. You always have to check. So I decided I would do a couple tests. I know it's not a multiple of 10. I know it's not a multiple of 5 because it doesn't have a 0 at the end. I know it's not a multiple of 2 because it doesn't have an even number in the ones column. But let's just check this. 1 plus 4 plus 7 equals 12. Now, if I remember my divisibility rules, if the number adds up to something that you can divide by 3, which 12 can be divided by 3, then I know that you can continue to divide this number. So even though I didn't know it, I could in fact continue to divide this number. This number divides nicely by 3. And when I divide 147 by 3, I get the number 49, which, by the way, kind of makes sense because it's so close to 50. 3 times 50 would have been 150. 3 times 49 is just 3 less than that, right? I should have known. Anyway, let's continue. 49, same thing. I hopefully know my 49 should ring a bell on my timetable. 49 is actually a number I can divide by 7, and it gives me 7. 7 times 7 is 49. 7 is a prime number. I can't break this one down any further. It only divides by 1 and by itself. So I know that's where I need to stop. So let's take a look at the numbers that I've divided with. I've got 2 5s, 2 7s, and a 3. So what that tells me is that for 3,675, that equals 3 multiplied by 5, multiplied by 5, multiplied by 7, multiplied by 7. And to write it in a more correct way, it equals 3 multiplied by 5 squared, because I've got 1, 2 5s, multiplied by 7 squared, because I've got 1, 2 7s. The biggest problem that students seem to have with this is that they don't stop at prime numbers. They stop before. So I've seen a lot of students stop, say, at 147, like I almost did, thinking it was a prime number, but never thinking to check. Got to check and see. It might be the only way. Or stopping at 49. I've even seen students stop at 4 or 8, thinking that they got it to a low number, but prime numbers are not low numbers. Let's take a look at that. Let's use a tree to look at 64. 64 I can divide a lot of different ways, but I'm going to go with the simplest way. I'm going to divide it by 2. That gives me 2 multiplied by 32. This 2 is going to stop right there. I can't break it down any further. It's a primary number. But 32 I can continue. I'm going to divide that yet again by 2. That's 2 multiplied by 18. So again, I'm going to stop that 2 there, and I'm going to break 18 down. And 18 is 2 multiplied by 9. Again, I'm stopping the 2. What's really key that people remember is that every time I get to a prime number, it stops. My tree ends there. That particular branch ends there. Well, I have composite numbers on this side. I have to keep going. 9 is also a composite number. Breaking it down would give me 3 multiplied by 3. 3 and 3 also prime numbers. So I've been able to stop right there. So when I look at my 64, 64 equals 2 times 2 times 2 times 3 times 3, and to place it more correctly, 2 cubed times 3 squared. That's my final answer. I've really got to make sure that I don't stop too early and I keep working down to my prime numbers.